Here is the answer key to the final exam open response section. Number one, as you can see, we have a regression model here. They want us to find the exponential regression equation rounding to the nearest 10,000. That's 4 decimal places. So we plug this in for L1, plug this in for L2. You hit stat, go to right arrow, arrow down, and you must copy down this equation. It's 1018.2839 times 0.5969 to the x power. They must be rounded correctly. You get 2 points each. It must be in equation form. You get 2 points for that. Then they ask, use the equation to predict how many coins would be returned to the box after the 8th trial. So you must show the substitution. You take 8, you plug it in for x right here. Here's the work, and it must be rounded to 16 coins, to a whole number. Even though it doesn't specify, you must infer that from the table. They want to know how many coins. Well, it's impossible to have half a coin, so the answer is 16 coins. Number 2, binomial probability. A mathematics quiz has 5 multiple choice questions. There are 4 possible responses for each question. Jennifer selects her responses at random on every question. Just that much information tells us that if you randomly guess on a question that has 4 possible answers, your probability of getting that right is 1 out of 4. The same is for a number cube, like a single die. If you roll the die, what are the chances that you can get a 6? Well, you're going to roll a 6 1 out of 6 times, theoretically. So that's how you get the probability. It's 1/4. Next, what is the probability she will select the correct response for at most 1 question? Well, since there are 5 questions, n equals 5, and at most 1 means 1 is the highest number it could be, she could also get 0 correct. So we must go ahead and set up our binomial probability equation, or our expression, which is 5 choose 1, right? NCR, probability of success to the number of successes, probability of failure to the number of failures. So we have our success is 1/4. 1 item correct, that means 4 are wrong. If she gets none correct, 5 are wrong. Plug these into the calculator, you end up with 405 over 1,024. This expression gives us 243 over 1,024. Add those together, we get 648 over 1,024, which is reduced to 81 over 128. So that is the at most part of the question. The at least part of the question, what is the probability she will select the correct response to at least 3 questions? Well, at least 3 means 3 is the least number it could be that she could get correct. So that means she could get 4 correct, she could get all 5 correct. So we have 3, 4, 5. So we have 5 choose 3, the probability of success to the number of successes, the probability of failure to the number of failures, right? These numbers always add up to n. 5 choose 4, 5 choose 5. And these are the powers that correspond. So you plug them into the calculator, we end up with these 3 probabilities. We must add them all together to get 106 over 1,024, which can be reduced to 53 over 512. That's how you get the full 10 points. As you can see, I've assigned points for everything along the way. Number 3, 10 teams competed in a cheerleading competition at a local high school. Their scores were as follows. How many scores are within 1 population standard deviation from the mean? For these data, what is the interquartile range? So again, this is a 2-part question. Well, how many scores are within 1 population standard deviation from the mean? You need 2 things. You need to know the mean, you need to know the standard deviation. So we plug all these into the calculator, and we find that 1 variable statistics gives us a mean, which is x hat, of 38.2. I give you 2 points for that. Standard deviation is 5.9. I give you 2 points for that. So within one standard deviation means you're going to add 5.9 to 38.2 to get 44.1, and you're going to subtract 38.2 minus 5.9 to get 32.3. So now we go through and we count up how many of these scores fall within one standard deviation. We have 1, 2, 3, 4, 5, 6 scores are greater than 32.3 and less than 44.1. Next question, what is the interquartile range? Well, if you arrow down on the calculator, you will see that the interquartile range is Q3 minus Q1. 41 minus 37 is 4. That's how you get the full 10 points on this question. Finally, number 4, this is the quadratic. A homeowner wants to increase the size of a rectangular deck that now measures 14 feet by 22 feet. The building code allows for a deck to have a maximum area of 800 square feet. If the length and width are increased by the same number of feet, find the maximum number of whole feet. Each dimension can be increased and not exceed the building code. Only an algebraic solution can receive full credit. Now, why do they say this? Because some people can guess, and they'll guess, okay, 8 plus 14, 8 plus 22, multiply those together. How close to 800 can I get without going over 800? And they guess and they guess and they guess, and some people guess 10, and that's the right answer. But we need to have an algebraic solution such as this. So we basically draw our original rectangle, which is 14 by 22. We want to increase it by the same amount. So we're going to add x. So we have x plus 22 times x plus 14 equals 800. We're not allowed to exceed 800. So you could also write this as an inequality, right? This has to be less than or equal to 800. We FOIL x plus 22 times x plus 14. It is so important that you FOIL correctly. So many people messed up with their FOIL step. X squared plus 36x plus 308 equals 800. In order to solve a quadratic, you must set one side equal to 0. We subtract 800, subtract 800, and we get 0 equals x squared plus 36x minus 492. We can't factor this. We could solve this using the completing the square method, but I prefer to use the quadratic formula. So we identify a, b, and c. A is 1, b is 36, c is negative 492. And we plug them into the quadratic formula. Now, if you plug in all the coefficients into the quadratic formula correctly, you get a couple points. That is true on the regions. Okay, now I start to simplify under the radical first. 36 squared minus 4 times 1 times negative 492 is 3,264. Then I take the square root of this. I write down all the decimal places. Plus minus means one of these is a plus, one of these is a minus. And then I evaluate the numerator, then divide by 2. I get 10.56571,371. And I get negative 46 point, et cetera, et cetera, et cetera. I reject the negative answer because this root is not feasible when we're talking about adding length to a deck. So we end up taking 10.56 as our solution. However, we must round down to 10 because if you go up to 11 feet, it would exceed the allowable area. In other words, if we went up to 11 plus 14 and 11 plus 22, we multiply those together, it would be greater than 800 square feet. 10 is the largest whole number that is allowable. So that would be 24 plus 24 times 32 would give us an area that is closest to 800 without going over 800. And remember, they wanted whole feet. So there you go. Best of luck with your test corrections. Good luck to you.